Jerry, take it away.
Jerry, can you start your camera?
I can't get my webcam to work. I tried to do this wirelessly, and I kept having dropouts. So I've plugged back in, and I don't have a webcam. So if it's okay, I guess I'll just have you drive the charts, and I'll go forward from here.
Jerry, you can actually control the slides by using the arrows at the bottom of the image.
Ah, okay. I will give that a try. Great. Okay, well, thank you for the opportunity to give this presentation. I'd like to dive a little bit deeper into the first part of what Dale was talking about a little bit more, the prospecting, the type and the scale of what we would need to do with respect to the lunar volatiles that have been discussed over the last several days. Before I dive into it, I do want to acknowledge from a terrestrial mining perspective, I've taken a lot of the understanding of prospecting and mining from work that Dale Boucher has done, as well as John Chapman, with respect to terrestrial mining and how it could be applied to space. As Dale pointed out, we have within the ISRU community been following the space mining cycle, or prospect to product. And as Dale pointed out, the really first and to a certain extent most important step is the prospecting step. First from a global resource identification perspective, and then diving a little bit into the weeds from a local resource exploration and planning. So just to make sure everything's clear, that we basically look at prospecting, the purpose, whether it's terrestrial or for space, for two reasons. One is to basically narrow down, identify, and characterize a small area for potential mining from a large area of possibilities. The second is, and Dale touched on this, is to actually begin the assessment of the economic feasibility of extracting those resources compared to the value of the product that you get out. Now, one of the things that's been very interesting working from the NASA perspective in space is that a lot of what we talk about prospecting has a lot of similarities to the data needs associated with the science missions and the data that has been discussed the last 2.5 days. You start with a global or area assessment. On Earth, you use satellites and planes. For the moon, we've used satellites and an impactor. But you start with surface topography understanding with items such as imagery and laser altimeters. You look at the surface spectrally with radar, gravity, and electromagnetic needs, instruments. You then start going towards the geological reconnaissance of the surface geochemistry. Again, type of instruments and understanding the surface features, the map, the minerals and such, geochemistry and the physical characteristics. And what's really important for both science and prospecting is to understand the geological context and the potential alteration mechanisms associated with the resources or ore body that we're going after. You have to obtain subsurface assessments, both with non-invasive measurements as well as invasive drilling and trenching. And to a certain extent, you have to start to integrate all of that data for analysis. So the phases, again, that we look at from a prospecting point of view is you break it down into 4. The global assessment, basically, if you look over here, taking very wide range surface maps, superimposing data about minerals and such. You then, once you've identified, say, a potential interesting location, you start your exploratory assessment. This is, again, mostly mapping and non-invasive instruments with a limited number of surface and subsurface samples. If you find a location that piques your interest, you then go into a much more focused assessment. You want to map the extent of the ore body or the resource using similar measurements and instruments that you used in the exploratory assessment, but to a much greater extent. And at this point, you're basically trying to attempt to calculate the volume of that ore body. This is a picture of the number of drilling operations of an ore body terrestrially, trying to intersect where all of the resources of interest are. And to a certain extent, if you don't do enough assessment, you can fool yourself. Here's a situation where you get the same data from 4 different drilling activities, but your resource could be completely different ore body. Once you've done this, you then go towards your mining feasibility aspect. Before you spend a lot of money actually mining the hardware or the resource, you want to determine if the types of processes that you're planning on using can work and are economical to do so. So another way of looking at that is, so from now jumping from terrestrial prospecting to lunar volatiles, this chart is just an extreme simplification of all of the discussions that have happened over the last couple of days and years in terms of where are the volatiles, from what samples have they been derived. We are, from a resource perspective, extremely interested in the polar volatiles that we saw that came out of L-Cross. The 3 to 10% water equivalent amounts, plus the fact that there may be some other very interesting volatiles, such as carbon monoxide, dioxide, hydrogen, ammonia, and different organics. So taking another look at terrestrial mining, here's a typical prospecting cycle. For lunar polar volatiles, we've been looking at a number of different orbital data sets, the neutron depletion amounts, what is the depth to stable ice, how long is there sunlight at that location, as well as how much light is at locations nearby that I could set up an outpost to support the mining operation. What kind of comm visibility do we have from Earth? Do I need a satellite for comm, or can I have direct communications to Earth? And what's the type of terrain for landing and setting up operations? From all of these data sets, you basically then select a potential site for prospecting. You now perform your first exploratory assessment, and if the results are not very favorable, you have to kind of go back to square one. Did I use the right data sets? Did I have the right hypothesis for where the ore body or resources would be? If you got a pretty good feeling that, hey, I got some good information, you now go to the more focused assessment. Once again, you may hit a null set of data that said, well, while it looked initially interesting, we had more of the situation like here than we had here at our location. So I think I'll go back to square one and try to find another site. If the data looks good, you now go on to your performing your mining feasibility. If for some reason the terrain is extremely bad, or you can't set up your mining equipment properly, or there's a particular contaminant in the ore body, that may drive you once more towards selecting a different site. In the end, you hope for this start of the mining for product phase. So from a perspective of what do we need to know to utilize the lunar volatile resources, we have a pretty good assessment from the orbital data sets that we've obtained through LRO, Chandrayaan, LP, and others spacecraft. What we really need to do now is go down to first the exploratory assessment to understand the resources. What is there? The minerals, the volatiles, what water, ice? How abundant are those resources? How are they distributed? Is it heterogeneously or homogeneously? And what's really important from an ISRU perspective is how much energy is required to process and acquire those resources and volatiles. We also need to understand the environmental impact on our hardware. What's the local temperature and illumination and radiation environment like? what are the physical properties of the regoliths? I believe Tony Colaprete has theorized that the L-cross material in Cabeus, in the permanently shadowed crater, was actually fairly fluffy on the surface. Other times, if you get to what Paul Spudis hopes is ice layers, that could be extremely hard material. Are there any other volatiles that are there that could be detrimental? We saw sodium and mercury, I believe, in the L-cross volatiles. Neither of those two would be very nice. So you may want to pick a different temperature at which the bulk of the water comes off, but not, say, the sodium or mercury. And then again, I need to sustain long-term operations. What type of, how does the environment handle or impact my processing for months and years of being there?
Hey, Jerry, do you have
So
90 seconds?
Okay, so we've pretty much taken the approach that we want to do this in a stepwise manner, taking those three questions: what is there, how extensive, and can I process it economically? And another way of looking at it is in these three phases, having an exploratory assessment, a short duration mission that looks at 1 to 3 kilometers, maybe 3 to 5 drill cores. There are 2 missions on the book that I'm aware of, the Resolve mission, which Tony will talk about a little bit more, or Resource Prospecting Mission 1. The Russians have considered some missions in terms of their Luna 25 and 27. If either of these 2 find locations that are of interest, we then would go to a more focused assessment on the order of 6 or more months, demonstrating and understanding what the environment is like and our initial extraction of resources, and then eventually going to our mining feasibility. And by being able to map the locations and concentrations of the resources, as well as examining our mining feasibility to determine things such as transportation, infrastructure, and logistics, NASA and other countries can make an assessment of, is it worthwhile processing that water? How much infrastructure is required compared to just bringing water and other volatiles from Earth, for example? I won't go into it, but I have shown other charts that basically show what types of instruments have been proposed for different types of prospecting missions. And on the right-hand side, I've included a list that if money was no object, these are the type of instruments that I would prefer for prospecting. And then I've broken down each one of the phases into a little bit more information and showing that, for example, we performed a field test in Hawaii in July of 2012, looking at how you would perform this early prospecting exploratory evaluation of lunar volatiles over a 1 kilometer area with 5 to plus augering and drill core assessments. That would lead to then a much more focused assessment of that same location, building 3-dimensional data sets of the ore body and volatiles, and eventually getting to your mining feasibility where you start to lay out what your mining community would be like. And with that, I'll come to an end.
Great. Thanks very much, Jerry. Really enjoyed that talk. There's a couple of questions that have appeared on the chat board here. The first one from Rishitosh Sinha at PRL in India. How soon do you think such experiments can be realized? I think that's probably going to be addressed in the next talk.
Yeah, to a certain extent, we're looking at, within NASA and the Canadian Space Agency, we're hoping to fly a mission called the Resource Prospecting Mission sometime in 2017 or 2018. I believe the Russian Luna missions are along those same timelines. So hopefully we'll be able to get some ground truth, early exploratory type data within the next few years.
Great. Thanks. And then the next question is from Pam Clark at Goddard. Would you comment on assessment with small distributed platforms with the latest in situ measurement instruments at much lower cost in lieu of one rover platform?
That's a good question. It gets back to which one are you feeling more comfortable that will define the ore body, and to what risk are you taking? Whether you use, say, multiple penetrators going into a crater or a rover, a single rover with instruments. Some of the community like the rover with the instruments more because you have a control over where your data set is being taken, as well as you're able to modify your hypotheses as you go along. So for example, when we started that field test in Hawaii, depending on how the data occurred and what was being seen by the instrument, you could replan your traverse and maybe focus on different geological features that would represent a better likelihood of finding the volatiles. Whereas if you just used, say, penetrators or a bunch of individual instruments, you may not be able to get that understanding. Okay,
great. Thanks. Let's see, one other question from Guntram von Kaparski. Are there treaty obligations needed or in existence regarding these lunar resources?
That's a question for the lawyers, and there have been many discussions about whether the space treaty allows for the use of space resources and under what conditions and such. Much of the community believes that that you can get past these. If a government like NASA, or like the United States through a government agency is using the resources for its own use, that may be totally different than, say, a mining company like Shackleton Energy selling it to somebody else. Those are discussions that I try to ignore and morely focus on the science and the engineering.
Okay. Let's see. We have two quick questions that perhaps we could answer quickly. The first one from Indu Varathara John at PRL. What precautions do you take about meteorite hits on the moon?
Well, that one, our first missions are fairly short in duration, so we're not taking any precautions. Just like we're taking minimum radiation susceptibility approach to keep our costs down. For longer-term missions in mining, you'll probably have to take much more.
Okay, great. And then we'll take one last question, and then the rest we can have in the discussion. This last one's from Brown University. There would certainly be different ore prospecting standards with respect to volatiles on the moon. Are any standards being developed as to what concentration would be mineable, or is it too early?
Here again, once we get the data from both what is there as well as how much energy and infrastructure is required to extract it, I think we can make our own economic assessment. That, again, when a government or a space agency is using the resource for its own needs, it has different criteria for what it considers economic than, say, a company that's selling it to somebody else.
Great, great. All right, well, thanks again, Jerry.